on TV, but this was one of the songs.
Yeah.
I was like, dang.
Laney is tired. Yikes. Yikes. All right, good luck today, Laney. We'll all pray for you. Okay. There ain't nothing wrong with her. All right. Anyway, here it is. Translations. Let's talk about it really simply. We're only going to do number 1. So translations are movement by vector, right? So the vector that's taking us from here to here, as you might notice, is a perfectly vertical vector, which means we have 0 change in the the x direction. So that's really easy. And then it looks like we're moving 1, 2, 3, 4, 5, 6, 7, 8 down, so that's minus 8. Everybody cool with that? Awesome. Well, A appears to be at 2, 1, 2, 3, 4, 5. B appears to be at 0, 5, 6, 7, 8. And C appears to be at negative 1, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, yep. And when we apply this rule, we'll get 2, 0, and negative 1. And then we'll get minus 8. When we subtract 8, we'll get negative 3, 0, and negative 2, which is the coordinates for our primes. Works out nicely, right? That's what a translation is. It's addition and subtraction. We picking that up. We cool with that. Translation by vector, super easy. When it's a perfectly straight line or perfectly horizontal or perfectly vertical line, then one of the things is going to be 0. Like for the second one, that's not going to be the case. Here's our vector, right? And so it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9 to the right. So that's a plus 9 in the x direction. And then up 3, so a plus 3 in the y direction. Everybody cool with that idea? Awesome. All right, I would like to move on from translations because honestly, translations are not that hard. If you're struggling with them, ask me for help, and I can fix it in 5 seconds. So if you are struggling, please tell me. I can show you how not difficult they are. Everybody cool? All right. Next page. We're going to do 2 of these. We're going to do the first one and the last one. We're finding the reflection rule, okay? So they have this line of reflection, and they have the thing here. Now, before I gave you both, and I said figure out the rule, I didn't need to do that. Because we know a reflection is going to be in this direction, right? Because it's over that line. And it's going to be the same distance on both sides of the line of reflection, right? Both sides of the mirror. So the distance here is going to be the same as the distance over here when it's flipped. Let me zoom in. That distance is 1, 2, 3, 4, 5 here, right? And when we flip it, it's still going to be 5. 1, 2, 3, 4, 5. So there's B prime. Everybody cool with that? When we reflect something, the reflection is the same distance from the mirror as the thing being reflected. Which is why when we reflect across the x-axis or the y-axis, it's really easy to do a reflection. We don't have to find the perpendicular line and do all the math behind it. We can just eyeball it, right? Does everybody see how to eyeball the reflection? Awesome. So A is going to be 5 away as well. So 1, 2, 3, 4, 5. There's A prime. Connect those up. That was a poorly drawn dot. So now we need the rule. When I flip over the x-axis, what kind of reflection is that? Is it a vertical or horizontal flip? Look at the thing. Don't think about x-axis. X means no. Look at the thing. When I flip over the x-axis, right? What kind of a flip is that? Vertical or horizontal? Vertical, right? Up and down. So we change vertically. Do we change at all horizontally? No, we do not. So no change with the x, because that's the horizontal. And we change vertically, so we get a negative y. Right? What once was positive 5 off the x-axis is now negative 5. Are we seeing that connection? So when I write my coordinates, for instance, A is negative 1, 5. A prime's coordinates are negative 1, negative 5. Yes. And that's true, right? So what happened? X stayed the same, Y changed. What was that face? Oh, okay. Fix it. How do we feel about that? Okay. I want to look at number 6. Because now things get weird. We're not flipping over the y-axis. We're flipping over a vertical line, right? But not the y-axis exactly. So what's going on here? Last time we had this, I gave you a false axis, and it was really goofy, and I was like, figure it out if you can. No one did. Now I'm going to show you how the magic works. All right. So here's what's going on. When I flip this, I know I'm flipping in this direction, right? What kind of a flip is that? It's not a rotation. It's a flip. Horizontal or vertical flip? Horizontal. So we're flipping horizontally, which means we're going to go from this to this, right? We change horizontally. Remember last time we changed vertically, we negated the y? But that was when we were flipping over the axes, right? Things are going to be different this time. So when we do this, let's eyeball it. When I flip A across here, what's the distance between A and this line of reflection? What's the distance between those? 3, right? So it's going to be 3 on the other side as well. So A prime is going to end up where D is. D is also 3 away from the axis. So it's going to end up 3 away on the other side, which just so happens to be the same spot as where A is. Is everybody cool with that? Right? They trade spots when you flip. It's because they're both the same distance on both sides. If A was further out than D, they wouldn't end up on the same spot. So Jenna, the distance between A and the line of reflection is 3, right? So it's going to be 3 on this side as well, which just happens to be the same spot as D. Same thing with D. It's 3 away, so it's going to be in the same spot as A when you flip it. Just happens to be. If I were to take something like this, here's my line of reflection, right? And I had a shape that looked like this. Here's A, here's D. A would end up here, A prime, because same distance, right? And D would end up all the way over here. Okay? So this one's just a coincidence that they both switch spots, because they're both the same distance on both sides. Okay. And then same thing with B and C, right? B prime, C prime, they trade spots. So let's write out what those coordinates are. So A looks to be -2. Again, count from the axis when you're doing coordinates. Count from here. -2, 1, 2, 3, 4, 5. Is everybody cool with how I got that? Make sure you're not counting from the line of reflection. You're counting from the axis, right? Start at 0, 0. 2 to the left, 5 up. Cool? Common mistake is for you guys to think that's the axis and count 3, 5. Don't do that. So we have -2, comma 5. B is at -2, comma 1. C, again, count from the axis. Start at 0, 0. It's 4. 1, 2, 3, 4 to the right and 1 up. And D is 4 to the right and 5 up. Is everybody cool with how I got those? I'll go darker so you can see the lines a little bit better. Sorry, this isn't. I think I took an old document and I didn't darken the lines before I made a copy. My bad. Now, A prime's coordinates, right, switches places with D. So A prime is over here. That's 4 to the right and 5 up. B prime is 4 to the right and 1 up. C prime is 2 to the left and 1 up. And D prime is 2 to the left and 5 up. Are we cool with that? So the question is, what is the rule? What's going on here? Well, we know at some point we're going to do this, because that's what a horizontal flip is. But then what do we do? So we're going to think in 2 steps, not just one. Before we get to here, we're going to go up here and then reach there. All right? First thing we do is we negate the x, right? That's what a horizontal flip is. So negate the x. That's going to be +2, +5. We cool? All right. Now, how do I get, after I did this, right? That's our flip. So we did our flip. Now, how do I get from here to here? what do I do? Plus 2 to the x, right? So what we did here is we did a vector, a slide, right? 2 to the right, 0 for the y. And that's how we get there. Now, does that rule work for all of them? Let's check it out. If I take this one and I negate it, I get 2, 1, right? Exactly, negate it, right? We do this first. We negate it because that's what a horizontal flip is, right? And then do I add 2 to get here? I do, don't I, right? Let's check this one. If I negate the 4, I get negative 4. What's negative 4 plus 2? Negative 2, right? Does that work out? This one, negate the 4. I get negative 4. When I do negative 4 plus 2, do I get negative 2? Yes. So the rule is I'm going to negate this, right? And then after I negate it, I add 2 to it. My bad. So that's the full rule. That's the full rule. I'm going to talk about why that is in a second. How did I get the middle part? Well, I knew it was a horizontal flip. Horizontal flip is negate the x, keep the y, right? Is everybody cool with that? And then after I flip it, I ask, okay, well, how did I get from here to here? I did a slide of 2. So the whole rule is this. Is everybody cool with that? So the rule is negative x plus 2, and then do nothing to the y. Now the question is, why is that? This line is in the middle of the shape. If we were to flip this shape over the y-axis, would it be in the middle of the shape? No. A would not have been here, right? It's only 2 away from this. So it would have ended up here. And D is 4 away from this. So it would have ended up 1, 2, 3, 4 here. How far are those off from where they're supposed to be? Here's D prime. Here's D prime where it's supposed to be. It's 2 off, isn't it? You need to slide it 2 to the right. Do you see A prime? How far is it off from where it's supposed to be? 2 to the right. That's where the plus 2 comes in. It's as if we said, okay. I see your line of reflection. I don't care. I'm going to go off of the easy line of reflection. That's very similar to it, right? I'm going to go off the axis. I'll flip it that way, and then I'll slide it over. It gets me the same dumb thing. So again, when you see this, and it's not on the y-axis, flip it like normal, right? And then ask yourself, how did I get there? Well, when I flip it like normal, I get positive 2 here. How do I make a positive 2 into a positive 4? Add 2. There's the rule. Negate it and add 2. Why does that work? Because it's really flipping it over this axis when you do this move, right? And then you get this. And then you add 2 to get it back into where it needs to be. If you get the first part, horizontal flip, so we negate the x. How do I get from here to here? I add 2. Do you get that? Then you're great. You're golden if you understand why that is. Because this first move is actually flipping it over the axis, which gets us to this and this. And then we slide it over 2, which is what this means. You're golden if you get that last part. How do you feel? Do you feel great about the first part? Do you feel pretty good about the second part? The explanation. Okay. Let's turn the page. We can come back to that if you need some more practice. All right. Number 1. This is rotation about the origin. I gave you the center of rotation. It's right there. Okay? So this is the stuff where the rule is really easy to figure out. Remember last time we couldn't figure out how to get the rule for a dilation that was off a arbitrary point, so we didn't worry about it. We're going to talk about that today. Okay? So first thing we got to do is draw our L's. I'm missing blue. Thanks a lot, ladies. Luckily, I have one of these. All right, so let's draw our L, and let's rotate C. 180 degrees. Doesn't matter which way I go, clockwise or counterclockwise. Nope, that's why they don't specify. You'll end up in the same spot. So look at the blue. The blue is here, right? It's pointing this way. If I turn it 180 degrees clockwise or counterclockwise, I'll get to the same spot. So I'm just going to turn it this way. Here's 90. Here's 90 again. Which way is it pointing now? To the right. So instead of pointing to the left, it's now going to do the same thing, 3, to the right. 1, 2, 3. Cool. Now look at the red part. It's pointing up, right? So now I'm going to turn it. Doesn't matter whether I turn it this way or this way, right? It's 180. So I'm going to turn it 90 and 90 again. Which way is it pointing? Down. So it's still attached to the blue like it was before, but now it's going to point down. How long? 3. The size of the L's do not change. And now that's where C prime is going to be. So we found C prime. Are we starting to remember this? We feeling good? All right, awesome. Let's do a couple more. B, notice, shares the same blue leg as C. It just is longer, right? So that's 6 in length to get to B. And then we go up 3 to complete the L. So our L is kind of like this, right? For B. So think about it. Which way is the blue line pointing? To the right. Oh, sorry, your left, your left, your left. Right? Correct? Your left, correct? Now I'm going to turn it 180. 90, 90. Which way is it pointing now? To your right. So instead of being here, it's going to go to the right from the origin. 6. See how it's 6 in length? We're rotating that and flipping it over to here. So now it's going to point to the right. Is everybody cool with that? This thing right here, we took that line and we rotated it 180 degrees. Now it's over here. Here, 180 to here. Chloe, how do you feel? All right. Now look at the red line. It's pointing up. Up 180 degrees is going to point it down. So it's 3 down, attached to the end of that blue line. So there's B prime. Checks out. Yes, ma'am.
I don't get how you know what side to attach that to.
Okay, so the red one, right? All right, before it was up, right? Focus on the individual piece. Ignore the blue, ignore everything else. Red is pointing up, right? When I turn that 180, 90, 90 again. Which way is it pointing now?
Down.
Exactly, and that's how you know to go down.
But I mean, like, on that side of the line instead of.
So the blue and the red are attached before, right?
Right.
This is correct. Yeah, like this. If I turn it 180, here's 90, here's 90 again.
Okay.
So it's still going to be attached after we're done, right? So I still know it's going to be attached to the end of this blue.
Right.
The question is which direction does it go, up or down? It's going to go down, right? Feel better? Okay, again, seeing it is the hard part. A shares the exact same leg as B, right? The blue leg. It shares it, right, from here to here. It just extends out further in the red direction. So here's the L for A. So it's going to be the same blue leg over here. It's just going to go further down, isn't it? It's going to go 3 further down. And there's our A prime. There's our final shape. Rotate it 180 degrees. What is the rule? Well, think about it. Here's our coordinate plane. When we're rotating about the origin, it's very simple. If something starts here, it starts plus plus. If it rotates 90, well, then it's going to end up here, right? 90 degrees counterclockwise. And if it rotates 90 more, it's going to end up here. So if I start here and I end up here, what happened to the signs? They both changed, right? This guy started here. So he starts over here. If I rotate 90, I end up here. Rotate 90 again, I end up here. That's positive, negative. What happened to both the signs? They changed, right? Negative became positive, positive became negative. They changed. When we say change the sign, we mean negate it. So the rule is negate your x, negate your y. It's very simple for 180 degree rotation about the origin. We can do those. Now, I could figure that out a different way instead of doing that. I could write all my coordinates down, write my new coordinates down, and see what happened, right? Negative 3, positive 3 became positive 3, negative 3, right? The signs changed. Yes. What makes them both negative? So 2 ways to figure it out. One, we can think logically. No matter where I start, if I start here and I go 180, I end up here. Both signs change, right? So negate this one, we get positive. Negate this one, we get negative. Another way I can think of it is I can write down my coordinates here and write down my coordinates there and see what happens, right? This was negative 6, positive 3. Now it's positive 6, negative 3. Do you see how the signs changed? Right? We would figure that out if we saw that over there. When it's about the origin, you can do this and figure out what's going on. Okay? Yes?
When you're doing the rotation, do you always have to start with the horizontal line?
You don't, no. You could have drawn an L like this for C, and that would work too. I always start horizontal because X comes first before Y, and I try to keep it consistent, but you might draw an L like this. That's perfectly valid. Okay? Yeah, so if you drew an L like this to get to C, that L would end up down here like this. Same spot, okay? Moving on. Let's look at the last one. Clockwise about R. Again, it's about the origin. We're just going to draw our lines, okay, and figure out what's going on. Here's the idea. Let's go for C first. Oops, I used the wrong color. Blue down here, red up there. Let's just rotate that and find the rule. The rest will follow. So if I rotate this clockwise 90 degrees, clockwise is this direction. So that red line, or I'm sorry, blue line is pointing this way. And if I go clockwise, that's this way for you guys, it's going to end up pointing up, correct? So blue line, which is 1, 2, 3, 4, 5, 6, 7, is just going to go 7 in the up direction from here. 1, 2, 3, 4, 5, 6, 7. Again, it was attached to the R. It's still going to be attached to R when it's done. Now the red part's pointing up. If I rotate that clockwise, which direction is it going to point? To the right. So it's going to go to the right 3. And there is C prime. Are we feeling decent about rotating our L's? Making the L's and rotating them. Again, break it down into the little pieces of the L, the red part and the blue part, and just think about which direction they're going to point. That's the key. Let's write down these coordinates and see if we can find the rule. Looks like original C is negative 7, positive 3. And new C prime is positive 7, positive 3. What happened to the coordinates? Peters.
Just the X is negated.
Exactly. Y stayed the same. Is everybody cool with Y staying the same? And then X is changed. How did it change? The sign changed, which means we negate it. Negative 7 negated becomes positive 7, right? Negative 7 times negative 1 equals 7. When you negate something, it changes the sign. How do you feel, Jenna? It's weird because you think, oh, negative X means the answer is going to be negative. It means it's going to be different than what you had before. Negative 7 times negative 1 is 7. Negating means change the sign. Did we change the sign between the 3's? No, so we kept Y the same. Do we understand that negation means change the sign, not make it negative always? That's a key. That's a common mistake. Are we seeing that idea? Bo, how do we feel?
Very good.
Okay, great. So that's the rule. The question is, why is that the rule? Look back here. If I start, pick a quadrant. 1, 2, 3, or 4. Pick a quadrant, Lainey. 2. All right, so if I start in 2, and I go 90 degrees clockwise, right? That's what this one is? Yeah. I'm going this way. What quadrant do I end up in now? 1, 2, 3, or 4? 3, exactly. So I end up somewhere down here. How did my coordinates change? Did this one change? No, it stayed the same. Did this one change? Oh, I went counterclockwise, didn't I? Yeah. How do you know? Because it's a different rule than what we did. My bad. I'm going this way, clockwise. I'm working in mirror mode because I have to flip everything for me, and then when I do it the same as you, I accidentally flipped it. My bad. So going clockwise. I go from here to here. How did our signs change? X changed, Y stayed the same. Here was our original X, Y. X changed, Y stayed the same. Remember, change, when we change the sign, means to negate. I know it's positive over here, but it was negative. Negative times a negative is a positive. Are we cool with that? Negation means change the sign, not make it negative. Half the time it's going to turn it negative, half the time it's going to turn it positive. Depends on what it was before. That's why that works that way. If we went the other direction, down here, we'd change the Y value, not the X. How do you feel? All right. Y, let's go.
Well, I tried doing it myself, and for A, I did it wrong.
Okay, so let's figure out where A should be using our rule. A originally starts out at negative 1, 2, 3, 4. Positive 1, 2, 3, 4, 5, 6. And using our rule, it says change the X, keep the Y, right? So we're going to keep our Y 6. And we're going to negate our X. If we negate negative 4, what do we get? Positive 4. So we'd expect 4, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6.
That's why I was confused.
Did I goof this somehow?
Yeah, it doesn't work.
Why did I goof this somehow? 7, 3, 7, 3. I went clockwise about R, 90-degree angle. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Did I goof something? What did I goof?
That's what, because
Yeah, that's what I got.
It's
Over 6 up 4. Oh, I goofed it. Right, over 6 up 4. So yeah. Sorry, I was going to trick you guys and then come back to it, and I forgot to come back to it. God, okay. Sorry, first hour. You were my guinea pigs. So wait, what happened? How did I do it wrong? What do you mean I switched it? Why do I have to go over 6 up 4? Isn't this 4, 6? This is not a rule.
Erase my pen. Yeah, thanks.
1, 2, 3, 4, 5, 6, and up 4. 1, 2, 3, 4. Something like that, right? A prime?
Why?
That's a great question. That's the only question. Sorry, guys.
What's the rule?
Yeah.
But
Right?
The actual coordinate that's what 4 or is it supposed to be 6, 4?
So what happens?
I guess that's 6, 4 prime.
Is C prime 7, 3? No. It's 3, 7, isn't it? So what really happened? We flipped the two signs.
And you get
Which one did we gate? This one got negated. This one right here got changed. Why did that happen? Why is that the rule? I mean, this made sense, and it still works. Right? The signs are going to change the way we said they would change. For this one, it's that, right? But why do they change spots? Why does that make sense? Do you see it? Noah, I think, pointed out last time. I may be wrong. Check it out. See this part? It's horizontal. When we rotate it, it changes to vertical. What was once horizontal, X, becomes vertical, Y. The X and the Y change spots. What was once a 7 for the X is now a 7 for the Y. And what once was a 3 for the Y now becomes a 3 in the X direction. Do we see how the horizontal becomes the vertical when we turn 90? And the vertical becomes the horizontal? Well, we represent that by switching the X and the Y. Why didn't that happen for the 180? look up here. I kind of butchered this thing now. See that blue? What direction is it going? Horizontal or vertical? After we flip it, what direction is it going? Still horizontal. So the x and the y don't change. How do you feel?
Confused.
I feel like
I know. Trust no one.
My neighbor was really pretty and then
Chaotic energy. I have far less than I had yesterday. You're welcome. Yesterday I had pancakes for breakfast. I took them off my plate, put them on the table, and ate them on the table. Because I could.
Did you eat it with syrup?
No.
What's the point of that?
okay,
When you have a set.
Everyone was like, make sure you keep the table clean. Don't make a mess.
Wait, you had a restaurant?
Do what I want.
Oh, so you were with other people.
Was I at a restaurant?
You're like 30.
Chaotic energy.
Do that. You're like 30.
Chaos. Because I can.
right.
That's the power of being an adult.
Chaotic Eve.
I know. I know. Laney. No. All right. This right here. What once was horizontal becomes vertical. So x and y change spots. Are we cool with that? That's the concept. There's a vine that says that. Or you can just look at the thing and be like, oh, look, they changed spots. Your mistake was you trusted me when I said, oh, look, C is 7-3. Oh, yeah, C prime is 7-3. No, it's not. It's 3-7. Okay.
I think you just messed up and then you're trying to play it off.
No, I've made mistakes before that were on accident, and I go, oh, crap, I'm a moron. What happened here is I made the mistake and let you guys play it off, right? And we did the thing, which totally would have worked, and then I forgot to come back to it. So that would have been really bad if I hadn't. Thank you for calling me out. Sorry. Sometimes I set those up and I forget to knock them down. Yeah.
So I tried to over 8 on my own. And I got like half of the L.
Okay, so notice for number 8, when you do it, you're not going to make an L for A. You're just going to make a line, right? So you rotate that 90 degrees clockwise. That's this way. So that's 1, 2, 3, 4, down. Here's A prime. We cool with that? B is going to be the same thing, just longer. B prime. And C is actually going to have an L. It's pointing down. When I turn it 90 degrees clockwise, it's going to point left. Is everybody cool with that? Pointing down, 90 degrees clockwise, it's going to point left. So it's going to point left from here. There it is. What's the rule? We're turning it 90 degrees. What once was horizontal became vertical. So y and x change spots. Which one do we negate going this direction? This is positive. When it goes down, it changes, right? So what once was x became this, and now it's negative. Yes. Whoops, sorry. Let me restate that. This was a mistake, not on purpose. X, negative, y, still negative. I agree with this. Why am I struggling with this? There we go. Yes.
Could you explain that now?
Okay, hold on. I've had
Yes.
my hand up.
So, look up here. If we start a point here, Taylor, and we go this direction, what happens? Stays the same, changes. God. Now I'm making a mistake. Now I'm making a mistake. I'm sorry. I'm blowing it. That was a mistake. That was an honest mistake. Look up here. I will explain. Look up here. From here to here. Did we change? No, stays the same. Did we change? Yes, so this one changes. Are we better now?
Why is the y in front of the x?
Why is the y in front of the x?
Why did they switch?
Vertical, or I'm sorry, horizontal right here?
Yeah.
and then it becomes vertical when I turn it.
Oh,
The x and the y change spots. Better now? I'm sorry. That's my fault. It's not okay, but I'm glad you understand. Yes?
Can you explain how you got C prime?
C prime? Yes. See how it goes 6 to the right here?
Yeah.
Then it's going to go 6 down. See how this points down? 90-degree rotation, clockwise, which for me is counterclockwise. So it's going to point this way. Did I goof that? Clockwise. Clockwise is this way for me. It's going to go this way for you. Sorry. I hope you can forgive me. I have to think in mirror mode. Yes.
I don't understand.
Okay.
So when you go from positive, positive, negative, the y change.
Mm-hmm.
But the C is in the third quadrant.
Okay, so I just gave a random example. If I were to start here in the third quadrant, 90 degrees to here, these, this one changes right here, right? Are we cool with that?
Yeah.
Is that better?
Yeah.
Okay, awesome.
So it's positive y and negative x.
Yes, right here. Yes.
I remember now. Wasn't there a rule that you wrote?
Y negative x?
Y negative x. But for a, if it's y negative x, then it'd be 6, 4, right?
Well, you just
And when you plot that, it's way bigger than the original one. That can't be the right rule. Can I have a new paper?
I was already confused. I'm even more confused.
In my defense, I'm doing this mirrored.
So turn around.
You're right. I need, yeah, good idea. Good idea. Let's do it this way from now on.
It's so much better.
Like this. Okay. Now I can do no wrong. All right, we're going to try and do it this way, and I'm just not going to suck. How about that?
Is it the short number Maybe if you put these on, it would be better.
wow.
Maybe it would. Why'd you steal my glasses, Jenna? All right, ignore this for a second. If you get this, you're going to be fine. Do we see how a rotation from here to here changes this, but keeps that? Awesome. Then you're golden. That's the key. Do we see how x and y change when we do a 90-degree rotation? It's because what was once horizontal becomes vertical. Are we cool with that? Wonderful. Then you're great. Yes?
Is that like graph can be up on the board for this?
Sure.
Yay.
Awesome.
You have a pen like that right on your desk.
So is this going to be
Not
like
yet.
the shorter quiz that we had? It's not like previous
Yes.
stuff?
What's your question?
So we have to know that we have to change the sign.
Yes, because what was once here rotates to here. Better? Okay.
I don't know. What are these? Showing like over this
No, not right now. I'm going to move on. I know. Dilation's about an arbitrary point. This is what your homework was over. It's the same thing. We're just drawing an L from here to here. How do you feel about that? Awesome. Do not worry about the rule. You'll be fine. No. Wait. That's what we just did.
So can I just draw that?
Yes. That's literally what we just did. We said it out loud. I just didn't write it down. Yes. Here's what I will do. I won't make the same mistake in third hour, fourth hour, and sixth hour. Sucks to be you guys. I will write down what we have been discussing for this on those videos. Which means by the end of the day, if you want, you can come in and see what I wrote down. But we have been saying this as we went along. That was the point. Okay? Don't worry about the rule for the number 10, 11, and 12. Yes. To homeroom?
Yeah.
Jenna, Lainey, are you guys in the same homeroom? Okay. There you go.
Thanks. I hope you have a better.
Yeah, me too. Writing is hard. What an embarrassment. Embarrassment to the craft.
Morning, Mr. Man.
Morning, Ann.